everyone, it's Coach Fred, and today we're going to be doing a SAT video on slope and rate of change. So linear functions is a main topic, is a major topic on the SAT. And so if we're going to talk about linear functions and linear relationships, we have to talk about slope and rate of change. So you may recall that slope is just a relationship, okay? A relationship between a change in one variable relative to another. Graphically, if we're looking at something and it looks like a line, graphically we would call the relationship between those variables the slope. But in real life, we would call it the rate of change, okay? And how do they relate? Well, the slope is a rate of change or a speed at which a variable changes over time. And on the SAT, you're going to have to be able to interpret and do different things with slope. So let's look at all the ways we can find slope or use it. So first, let's recall from geometry that if we have parallel lines, they have the same slope. And if we have perpendicular lines, they have opposite reciprocal slopes. That's going to come into play as well, and I didn't want to forget to mention it. Opposite reciprocal slopes. All right, so now let's get to slope. So first, you have to be able to feel comfortable with finding slope using a formula. So depending on your teacher, the variable that we always use for slope is m, and your teacher might have said, okay, I want you to think of it as a change in y over a change in x. And they use the delta symbol or the triangle symbol, which just means change. So change in math really means to subtract, to find the length between, the distance between things, which means we can subtract them. Some teachers like to get you to use rise over run. Now you might notice that I spelt rise incorrectly, and I'll tell you why in a second. But most of the time, I think in Algebra 1, you learn slope using a formula. And that formula is y2 minus y1 over x2 minus x1. That means change in y over change in x. And y2 and y1 just mean different points. And now you might see why it is that I use rise over run, because we have to remember that it's always the change in y in the numerator and the change in x in the denominator. Okay, so let's look at that formula, okay? Let's look at the formula, because this is something, the slope formula, is something that you're going to have to know how to use. It's not going to be given to you on this test. So whichever way you remember it, it is something that you're going to need to pay attention to. Okay, so let's use it. So each of these points represents an x and a y. So this is an x and a y, and this is an x and a y. And so in math, the way we differentiate those is that we use x1, y1, and x2, y2. Now, it really doesn't matter which one you call which. You can use whatever order you like. I tend to use the larger number as my y2. So I'm going to do 9 minus 2 all over 8 minus 2. And so my slope would give me 7 over 6. All right, so that's how you use the formula. You just plug in the values and you evaluate them at those points. You might have to find a slope from a table. It could be just a plain old table like the one I gave you. It could use function notation. The table could say x and f of x instead of y. The table could also be given to you horizontally instead of vertically. Regardless, you just have to do the change in y over the change in x. So the way I do it is I think all of these are points. So I just look at the difference between -3 and 0, and I notice what I'm doing from -3 to 0. So this, I'm going up 3. From 0 to 3, I'm going up 3. From 3 to 6, I'm going up 3. And from 6 to 9, I'm going up 3. So the change in all the y's is 3. And then I look at the change in the x's. It looks like I'm going up 4, and up 4 again, and up 4 again, and up 4 again. So I look at the change, I use that little caret, that sideways caret symbol, and then I can see that my slope is 3 over 4. Now, it doesn't always have to be the exact same number. For example, I could have over here the number 15, and over here the number 23, where I'm actually going up 6 and going up 8. But because slope is a ratio between the change in y and the change in x, 6 over 8 is the same ratio as 3 over 4. So the slope would still be 3 over 4. All right, so you could also be asked to find slope from a graph. Now, the one thing you want to be careful about with the graph is you always want to look at the scale. You want to look carefully at the scale. Because what I have found is they ask you about slope in real life examples and they make the scales different. You learn scales usually are 1 to 1. So just be careful because usually they could put like 10 along the x-axis and 2 along the y-axis. So just be really, really careful. But then you can calculate your slope by doing rise over run. So I like to find index points. Those are points that go right through a corner, like these two. And so I would rise, I went up 2, so I rise 2, and I run to the right 3, which is both in positive directions, so that would be 2/3. Now I could also go in the opposite direction. I could start here and go to here, and that means I'm going down 2, so I actually indicate that with a -2, and then I'm going to the left 3, which I would indicate with a -3. But if I put them over each other, rise, change in y over change in x, I still get 2/3. So it doesn't matter. Now I could also, if I really wanted to, start here and go to here. And that would be a rise of 1, 2, 3, 4. So up 4 and to the right 1, 2, 3, 4, 5, 6. So 4 over 6 gives me, again, is still that same ratio of 2/3. Okay, so that's how you use slope. Find slope from a graph. And the last one, and where you're going to have to really be able to interpret slope, is slope in linear equations. So I have found that they ask you about the slope in 2 different equations. They ask you about slope-intercept form. They ask you to interpret slope-intercept form. So slope-intercept form is y equals mx plus b. Okay, where m is the slope, okay? So let's look there. Y equals mx plus b. M is the slope, and 0, b is the y-intercept, okay? So when you're looking at y equals mx plus b, we have to be able to interpret what the slope is. And the slope is the rate for every 1x that y changes by m. Now, that's a lot of words, right? And I'm going to show you that in another video on exactly how to interpret that. I do want to let you know, though, that they get a little tricky by sometimes asking you for the slope in b plus mx form. They use the commutative property and they just flip that around. So you want to be really careful to make sure your slope is m and it's always multiplied by x. That's how we know it's the slope. All right, and then the other form that they ask you often about would be, or give you, is standard form. I find standard form is on the test a lot, and standard form is ax plus by equals c. And in your classes, you probably learned the relationship with a and b and how they relate to slope. So I'm hoping that you learned, but I want you to get it into your toolbox, that to find the slope, if it's in standard form, a nice shortcut is to do negative a over b. Negative a over b. And that shortcut can be really helpful for you. So to find the slope in standard form, you do negative a over b. So let me show you an example of that. So I give you 3x minus 4y equals 8. So again, if it's negative a over b, 3 is the a and negative 4 is the b. So I would do negative 3 because it's negative a over b, which is negative 4. So my slope would be 3/4. I want you to think about this because this is a really quick way to do it. If you try to put this equation in y equals mx plus b, it's just going to take you a lot of time. And this is a nice shortcut to save you some time on the SAT. All right, guys, so those are some of the basics on slope that you're going to need for the SAT. I want you to think of this as video part 1. I'm going to be giving you the different ways you might see it in a couple videos that follow. So have a great day. Hope that was a good reminder video.